this. Okay. Again, these are step functions. The graphs will look like stair steps every time. They'll actually just look like the tread. You know, the part that you put your foot on when you walk up a set of stairs? Just the tread that you step on. That's what they're going to look like. They are also piecewise functions because they're a bunch of pieces. They aren't connected. So instead of, like when you draw a set of stairs, you know, you have the sort of rise going on. These are just the runs. Just the treads, just where you put your foot. Okay, here's the new notation. This is called the greatest integer function. And it kind of looks like a bracket and an absolute value sort of mixed together. You draw it like this. So it's like you make a bracket, and then you double bar it. That is the greatest integer function. I'm going to draw my x better. There we go. This is a step function. Whenever you have the greatest integer function, your graph is going to look like a step function. Okay. So make sure you draw that bracket with the double barred bracket. Here's what the greatest integer function means. Now, here's the name is confusing because it makes you think you actually want the biggest number, but it's actually backwards. I don't know why they named it that. That's just what they named it. Because here it happens. It's the greatest integer less than or equal to x. So the greatest integer function is either equal to the value inside of it, if it's an integer, or it's the next lower one. The greatest integer less than or equal to x. So it can be equal to it if what's inside of there is already an integer. If it's not already an integer, it will go down to the next integer. That's what the greatest integer function does. And I understand why that sounds confusing. But after a while, we have to... The biggest issue that we have here is trying to find out how wide these steps are. Okay? And I'm going to show you how to find very specific points and then how it works sort of in between those points. Okay? And then how to draw those steps. So let's look at an example here. So again, we're going to graph the function and then we're going to identify the domain and range. In this particular example, we have h of x equals the greatest integer function of x minus 5. And we start off sort of simple, basic, with our regular old t-table. And the easiest number we ever use to plug in is what? 0. 0 is always the easiest number to plug in, right? So that's where we're going to start. Little t-table. I'm going to start with 0. And plug that in. And then we're going to figure out what that equals. All right. So I have the greatest integer function of 0 minus 5. What is 0 minus 5? Negative 5. That equals the greatest integer function of negative 5. Is that an integer? Is negative 5 an integer? Yeah. Yes. So it is therefore, again, the greatest integer function is equal to an integer or the next one lower than it. Since this is equal to an integer, it equals negative 5. So what this means is I have a point at 0, negative 5. 0, negative 5 is on the step function. It's on the graph. Okay? What number should I look at next? 1. Okay, so let's do that. Let's plug 1 in. You go ahead and finish that one. Finish finish 1 and see what it equals. All right, what does it equal when I plug 1 in? Negative 4. Okay, so when it's an integer, it stays an integer. Now, I'm going to stop with those two numbers because I want to talk about what happens in between there. Now, what I'm going to write down, you can write down if you want, but I really want you just to pay attention to what I'm doing. Because what we're going to determine is how long this step is and what happens, how the greatest integer function actually works. I'm going to plug in 1/2. Again, you can write it down if you want, but I want you to pay attention more to what I'm doing. Because we know that when x equals 0, y, or h of x in this case, equals negative 5. We know that when x equals 1, h of x equals negative 4. What we don't know is what happens in between 0 and 1. Because once we can figure that out, whatever that pattern is just going to continue the rest of the way through the problem. So I'm going to plug in 1/2, 0.5, right? So I'm going to plug that in, and I plug it in the same place. What is 0.5 minus 5? That's a minus. That's a bad-looking minus. Here we go. What is 0.5 minus 5? What? Negative 4.5, right? Negative 4.5. So now we're in a situation we haven't been in yet, okay? Inside the greatest integer function, we don't have an integer anymore. Now, the greatest integer function takes whatever number's inside of there, if it's not equal to an integer, and moves it down to the next lowest integer. What is the next lowest integer to negative 4.5? Yeah, raise your hand when you know. The next lowest integer from negative 4.5. All right, 3 of you know. Cool. Nobody else knows? The next lowest integer after negative 4.5 or before negative 4.5. Jacob, what is it?
Negative 5.
Oh, that's right. We have 2 Jacobs. I forgot. Negative 5. How many agree with Jacob that it's negative 5? How many think it's something different? What do you think? You think negative 4 is smaller than negative 4.5? I know the negatives mess you up every time. Yes, you are correct. It is negative 5. So this greatest integer function, if I have negative 4.5, it is also equal to negative 5 because it takes it to the next lowest integer. Now, here's what I want you to see, okay? Let's say I put 0.9 in there. Then I would get negative 4.1. What's the next lowest integer? It's still negative 5. Again, it always goes on to the next lowest. What if it was 0.2? Then this would be the absolute value. Greatest integer function of negative 4.8. That's also negative 5. So what happens is anything between 0 and 1 goes to negative 5 until it turns to 1. And once x turns to 1, it jumps up to negative 4. Any decimal values that you put in between 0 and 1 will go to negative 5, which tells me that this step is 1 unit wide from 0 to 1. Okay, but it's at 0, it equals negative 5. At 1, it doesn't equal negative 5 anymore. So how we write that is this way. Okay, so from 0 with a closed circle, less than or equal to x less than or equal, greater than or equal to 0, but less than 1, the y value is negative 5. For that entire length, from 0 to 1, that's how long the step is, 1 unit. And as soon as x equals 1, it jumps up to negative 4. Well, how wide is that step going to be? It's going to be 1 wide again. And so we're going to have this pattern. So when x is 1, x is greater than or equal to 1, but then at 2, it jumps up to negative 3. So once you establish how wide the step is, you're going to have this pattern that looks like this over and over again. And it's pretty much always going to look like that. Now, that being said, the step isn't always going to be 1 unit wide. And what you're looking for, how did I know that this was going to be 1 unit wide when I looked at it, is what value, how far away do I have to change it to go from negative 5 to negative 4? Well, in this case, As soon as I plug 0 in, I had -5. I plug 1 in, I get -4. So you're going to want to look for those kinds of things. And then you'll see a pattern that goes on with the coefficient on x. So now we have to graph it. And here's what that looks like. Okay, again, this means the step is 1 unit wide. I would write that down, actually. The step is 1 unit wide. So again, once you find the pattern, it just repeats over and over again. So let's look at the graph now. So this I just copied from the other screen, right? And we're gonna graph this first one. So what this is saying, again, when x is 0, y is -5. So I have a point right here. Okay. When x is 1, y is -4. So I have another point right here. But keep in mind something, and I'm going to zoom in on this a little bit. So keep in mind something. What we said was that y equaled -4 for all these decimals in between 0 and 1. And then it went, so all along here, this little horizontal, where y equals -5, all these decimal for x will produce a -5 until I get to 1. And then at 1, it jumps to 4. So how we do that, how we indicate that is we draw a little step, and then we have an open circle right there. So that tells me that every value, including 0, on up to 1, not including 1, will produce -5. And that's what I was trying to show you with all those different decimals I put in there. That the greatest integer function keeps all those values at -5. And then the same thing is true for -4. If I plugged in 1.1, 1.2, 1.3, 1.4, 1.5, 1.7, 1.9, those are all going to go to -4 until I get to 2. And then at 2, it jumps up to -3. So that's what the steps look like. One side is closed, one side is open. Right? And then after you establish, I'm going to zoom back out. Okay, that's what we're looking at here. We've established the pattern. You don't have to do any more than this. The rest of the steps will follow the pattern. So from here, put a handful of steps above, a handful of steps below, copy, paste, however you want to do it. And there's a graph of the step function. See, it looks like a bunch of stair steps. And technically, they go on and on forever, so draw a couple arrows just like we would. The key is figuring out the first few steps, first couple steps, and once you do, the rest is just repeating the pattern. Now, believe it or not, that's sort of the easy part. The domain and range is a little tougher. Actually, domain is not so bad. Okay? Because we got to find the domain. Again, I'm going to zoom back in on this so you can kind of see what we're talking about a little closer. So if I start over here, whatever this value, this is x value of -2. There's no gap. I stay on it. I'm moving on to x's. Now all of a sudden I'm not on it anymore. But it jumps up to the next one. So I'm still okay. 1 is on the graph for x. Then or -1. And then I kind of keep scooting, no gap. Boom, then I jump to that one. Keep scooting, jump to that one. There's no gap as I move from left to right. Okay? No x gap. So what is the domain? Yeah, Isabel. All real numbers. There's no gap. I don't skip any x's. Okay? So my domain is all real numbers. Now for the range, it's different because if I start at the top here and I move down, I jump from 1, and there's none of these decimals in between, to 0. There's this huge gap in here. Then I jump from 0 to -1. There's a gap in there. Okay, I have all these gaps. I have a gap here. 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 There are no y values in any of those places that I highlighted. What are my only output values for y? Like, what is the y value for this step right here? The y value for this step, what is it? 1. What's the y value for this step? 0. What's this one? -1. -2. What are these numbers? Integers. So math's everywhere. The range is z for integers. So yes, you could write the word integer, you could write the words all real number. But step functions are going to work like this. And the step functions you're going to work on are all going to be greatest integer function. Make sure, again, one side is closed, one side is open. That's important. For the most part, it's going to be left side closed, right side open, but not always. Just be careful on that. Okay?